Standing here with David Bugiani from Movion, extended platform for managing and monitoring the life cycles of infrastructure. Smart road users require smart infrastructure, right, David?
Yeah, right.
Okay, the stage is yours.
Okay.
Can I get a big warm applause for David, please? Thank you.
Sto seduto. So I can start.
Yes, you can start.
So good afternoon to everybody. I'm David Bugiani from Movion. I am the head of infrastructure management in my company, and I'm here to explain you what is ARGO. That is our extended platform for managing and monitoring the life cycle of the infrastructure. First of all, I'd like to say some word about our company. We are leaders in the development and integration of ITS solution, tolling, and infrastructure management. And we are the center of excellence of Autostrade per l'Italia for research and innovation. We love to define ourselves digital engineers for mobility because we integrate and implement solutions to design the future. That for us is something that must be intelligent, powered by technology, and something that is always growing. So, why we decided to develop and to implement this platform, ARGO? We face a big challenge because in Italy, but also in Europe and in the rest of the world, there are several old infrastructures, like bridges. Many of them have been built like 50, 60 years ago. So these critical infrastructures needs to be inspected, maintained, and keep under control during their whole life cycle. Why? Because these kind of infrastructures need to be maintained safe in a secure way, and this kind of inspections and maintenance process has evolved too during the time. So at the beginning and also now they are strongly manual operations. So there are literally operator, inspectors, people that need to go under or over the bridge to see how the bridge or the structure, the asset is behaving. So if there are some problems, some damages, and we noticed that in this process, during the time, there is always some innovative component that is coming inside the process. So a continuous digitalization of the process itself. In addition, by our experience, we notice a lot of emerging technologies that can be integrated in this process of maintenance and monitoring, and that can help us gathering different data that can be mixed together with all the data that usually are seen during the manual inspection to give an enrichment to the information that usually are involved in this process. So we have this challenge, and we develop a platform and we have a goal, which is we want to have in a single platform something that help us in handling the whole life cycle of the infrastructures. To fill this goal, we have to reach some sub-goals, some intermediate step. So first of all, we needed to fully digitalize all the information related to the assets and to the inspection. So we digitalize the assets, we digitalize the process that insists on these assets. Once that we have digitalized everything, we can be sure that everything can be handled with transparency, we can apply data control, and we can increase the productivity, the efficiency, and reduce the cost of all the processes, for instance, the inspection process. And since we are working for our main company mainly, we, since the beginning, design our solution to work for many, many assets, thousands of bridges, thousands of structures. So our platform has to be modular, scalable, and so this is one of the main main issues that we face during our development. So our platform is ARGO, that is the extended technological platform that reach these goals and that is designed to manage and monitor the infrastructure's life cycle. The platform is composed by 4 main components: the digital inventory, the inspection process, the digital twin, and the monitoring and IoT. All these components works together in a strong synergy. So the digital inventory is the core of the application, is the database, the asset management that contains information about the assets, the structures. The inspection process is the set of processes that insists on this data and that have been digitalized by us in order to work in a traceable way. The digital twin is a digital version of our asset on which we can do some operations that usually are done on the physical, on a real asset, and we try to move this kind of operation in a digital world. Last but not least, the monitoring and IoT components is the part of the solution that gather information from the field and that bring them to the digital inventory and mix them with all the other components. The strength of our solution is that ARGO, even if it's quite innovative, has already been applied to Autostrade per l'Italia. That is the biggest, the largest toll operator in Europe. This is a sort of guarantee that our solution is robust, flexible, and scalable. And here on my back, there are some figures about Autostrade per l'Italia. I'll cite only the most important. So we have almost 3,000 kilometers of road with almost 3 million of daily users. We have 5 concessions, more than 2,000 bridges, 422 kilometers of tunnels. So our solution has to work with these figures. So it has to be scalable and modular since the design phase. So let's go a bit deeper inside the 4 components that I described before. First of all, we have the digital inventory. The digital inventory is a digital archive of the infrastructures that is based on IBM Maximo, provided by our technological partner IBM. In this digital inventory, we put all the data related to the asset. So we start with all the information that you have related to your asset, to your structures. So if you have master data, data related to positioning, design drawings, we have defined a standard process that starting from this set of information allows you to produce a discretized version and a digital version of your asset in a unique and fully replicable way. So you start for this information and then you can fill a relational database, something that can be measured, something where you can retrieve data. And this digital inventory has been already applied to Autostrade per l'Italia too. So we have already discretized and decomposed more than 2,000 bridges, 1,800 overpasses, and it leads to 650,000 components inside our asset management. To reach this goal, we have defined the 4-level hierarchy. So every structure can be decomposed in a sort of graph. So we have organized information, not only a decomposed information of a structure. And this kind of organization is useful because it enables us also to build and to obtain building information modeling automatically generated from all this data. So we fill a database, then we use all the data that are stored, like the ingredients of a recipe, to build this simplified 3D model. This kind of 3D model is something that is very useful, and it has 3 main purposes. First of all, it makes it possible for the users of our platform that works on the main application to see how is the structure, how is the bridge, for instance. Second, you can use, as I explain later, it is possible to use this 3D model also in the mobile app that we provide with our solution. And third, we have a side effect because If you build this kind of model in an automatic way, it is possible to use it to validate the data that you have put inside your system. Because if you put the wrong data, you have a strange bridge, and you visibly notice that you have put something wrong inside your system.
I have a question. I have a question. Can you see water with your when you monitor it? Is it possible to see water? Now I see like trees and those things. But do you have a lot of water in Italy?
We have a lot of water, yeah. We have viaduct and bridges that usually cross water, but we don't model water in our...
So you can't see it, just the
We see only the structure.
Okay, thank you.
Only the structure, yes. We have generated more than 2,000 3D model. For each, in fact, for each bridge of Autostrade per l'Italia, we have already generated the 3D model, so we can quite be sure that our algorithms works for every kind of bridge. We have seen many, many samples of bridges, so we are quite confident of this concept. Going through the application to the second component, the inspection process, as stated before, we have already digitalized many processes. First of all, the inspection one. So the whole inspection is done, can be seen as done by with some macro steps. So first of all, we have the planning phase. So you have to plan the inspection on the web application. Then you have the execution of the inspection that you can do with a mobile app that is fully integrated with the central application. And you have a report that is digital signed. So you plan the inspection in your system, then you assign the inspection to the operator, to the engineer that go on the field. They go on the field with a tablet, and using the tablet, they can be guided in a clear, traceable, and totally auditable process. So they can use the 3D model to check all the components of your bridge or of your asset. You can check which kind of components you are seeing, what you are controlling. You can check the presence or the absence of defects, for instance, the damage that you see in the picture for each component. You can give some metric about it, and you can store this data. In the end of the process, you have to go back to the main application. You can collect all these data, and you can produce a report that has a digital signature. So everything that is also, for a real point of view, correct. In some way, we brought on this kind of digital platform all the processes that we have in our experience from decades of our main company, Autostrade per l'Italia. Also, this part of the project has been already applied in production. So in 2021, we have done 2,000 inspections with our system. That leads to 150,000 pictures gathered in the central system. For this year, we have already planned 8,000 inspections, and since we are at the end of the first quarter, 2,000 of them has already been completed. Now, let's go to the most innovative part of ARGO. Because what we have seen up to now is the digitalization of everything that we have always been done in Autostrade. So the inspection has already been done, and we have digitalized this kind of project. We do them in a better way, in a deeper way, but now we are trying to go a step further on a next level, a sort of inspection 2.0. So we start to describe it. We use the Sette Fonti viaduct, that is a representative viaduct of Autostrade network, on which we work with the digital twin and with the monitoring, since we want to have a different kind of inspection that I'll explain later, and try also to go beyond the visual inspection and try to predict if there are some problems and work on data that comes from the field. That's why we apply the IoT. So we have the digital twin that we do. We collect and produce digital twin of our bridges because our goal, our focus is to do remote inspections. So all the inspections that now the operator, the engineers do going under the bridge, over the bridge, physically on the field, can be done remotely. Every inspector, in our vision, could do this kind of operation directly from their office. In order to enable this kind of feature, we have to produce this kind of 3D model. Our digital twin up to now is only a geometrical and visible digital twin. So we gather information with drones equipped with high definition camera, LiDARs. We reproduce with aerophotogrammetry the 3D model with the texture, and when necessary, we use LiDAR to have a more precise geometry of our structures. With this kind of representation, it's possible to do the visual inspection also from an office. The main advantages of this approach is that you can have less impact on the traffic, of course, because you don't have to use by bridge. You have an increase in safety because you don't have to send people under the bridge, and you can do it, let's say, with calm. You can check the same bridge for several operators from different computers, so you can have a replicable solution. So we see many, many advantages in this approach. Since we wanted to help the engineer, the operator, to do this kind of remote inspections, we are working to put in the pipeline also some steps of artificial intelligence to detect damages or defects in our structures. So we gather information, we gather images, we apply artificial intelligence in order to detect if we can classify and measure this kind of defect, and we apply to the images these labels that you see here. Once you have this kind of label, you can apply it also to the 3D model. So during the remote inspections, you don't have the plain 3D model of your bridge, but you have the 3D model with some suggestion. So it is a support the decision system for the operators. Yeah, I think that's going on to the last component of the platform, the monitoring and IoT. As stated before, we don't limit ourselves to the visible inspection. We want to go a step further. We would like to see if studying some behavior of the structure is possible to predict, to be a bit in advance to eventual problem on our structures. To do so, we think that one way using sensors and IoT. So on this use case of Sette Fonti, we over-equipped the structure, so we put more than 600 sensors of 13 different types. For instance, accelerometers, clinometers, crack meters, string gauge, optical fiber, many kind of sensors. Maybe too many. And yes, we have more sensors than concrete on this bridge. And so with all these sensors, we can monitor at the same time the dynamic and static behavior of the structures, and also global and local phenomena. So we check a lot of different features. And we are aiming to define an optimal layout, so it's something that is scalable for all our structures, because it's important to keep in mind that we want a solution that works for an operator that has thousands of structures. So we don't want to monitor one bridge or one tunnel. We want to monitor thousands of them. So we need something that is scalable also in the process of the installation. So we try to define which is the optimal layout and which are the most significant structural parameters that we want to investigate. All these data that we gather from the field are brought to the central system and integrated with the other platform. Here we have a very simplified version of the data flow that we have in our solution. So we have the sensors and data that passing through the on-site gateway, that can be a radio one, usually based on LoRaWAN, or a cabled one, a wired version of the gateway. We pass all the information via industrial standard brokers. For instance, we use both Kafka and MQTT protocol to the central system. Here we have all this information mixed with the digital asset registry that I explained before. We store them also on Amazon S3 on the cloud. So we have the capability of the cloud, the theoretically infinite space to store all the raw data that we could need in the future. And all these data then are visible to the user with some dedicated interface. So the users can configure sensors, can see which are the raw data, metric, advanced algorithms. It's possible to do analytics. Everything is integrated in a unique solution. So to sum up what I have tried to explain up to now, in ARGO, in a single platform, using the 3-4 components that I explained, so the digital inventory, the inspection process with the digital twin version, and using the structural health monitoring, we have enabled several further steps on which we are working and we can continue working. So it's possible to perform structure assessment. It's possible to produce deterioration modeling of our structures. It's possible to do predictive model or predictive maintenance of our structures using analytics based on this data, on the digital twin. And all of these bring us to have a cost and time optimization. For these reasons, for us, ARGO is not only a platform that has already been in production and that has already been used on thousands of structures for thousands of inspections, but is de facto an open platform, something that can continue growing, and something on which we will continue to work to fulfill all of these further steps.
Thank you. Is it the last one? Last slide?
Yeah, yeah.
Thank you, thank you, thank you, thank you, thank you, David. I had a question. The drones in Italy, is it easy to let them fly there? Is no privacy or the government who says, hey, you have to go down right now?
Yeah, this is a tricky topic because it depends. It's not so easy to fly near structures like a bridge because usually a bridge can be also over a street. So you can't fly over a street if your drone is too big. You can't fly over a private house, for instance. If you need pictures of part of the bridge, you may have to cut some trees. You can have very old trees, so you cannot cut them. So yes, the operative part of this data retrieval is not so easy, but we work also on this topic.
Thank you. It was really interesting. I think I will build a bridge in my home for 3D version. I hope. Do you have a question? Is there any questions? Raise your hand, please, if you have a question. Are there any questions? If you have a question, you can also visit him at stand 01308. And he will stay here like for 6 minutes. So please ask him a question. And thank you all for coming. And David, thank you for your presentation.
Thank you for this
Please give a warm applause for David Bugiani. Bugiani? How is it?
Bugiani.
Bugiani. Thank you.